into the play. In this era, 1010 to 1030, lots of AI things will come. All these systems are based on AI, intelligent sensors are coming, sensors fusion is happening due to AI. But beyond 2030, the age will come when there is a smart actuation will also take place in our market. By the help of that, we will get driverless car, that is autonomous vehicle. We'll get concept of smartphone. Now we are having concept of smartphone, but that time most of the houses will be smart. Space travel, there is aerospace, there is smart actuating in aerospace devices, telekinesis, robotics, and physics, everything will happen. So there is a new era of actuation will come just after 9 years, that is in year 2030. So this is the state-of-art smart sensors, and this is the 4th generation sensor where you can see that the microcontroller is embedded inside the sensor. So what will happen, it can easily interface with the outside world with communication bus, and we can put some logical instructions inside it. And the sensing element is no more a normal sensing element, it is called MEMS. The full form of MEMS is, is micro electromechanical systems. So micro means, we know micro and micron is 10 to the power minus 6. Means if we try to realize it, means it is 1/10 the width of human hair. So it is almost invisible in normal eye. And without mechanical or electrical, any system cannot stand. So if actuation is there, there must be some mechanical part, and electronics part also be there, because we are having ADC, because all the signals available in this world, in this real world, are analog in type. But when we are communicating with computer or microcontroller, it is in the form of digital signal. So ADC is required. So electronic instrument, and when we are driving a motor, electrical instruments are required. Hello, any query? So this micro electromechanical system is not a single sensor or actuator. It is a system. It is having sensing part, it is having processing, signal conditioning, this microcontroller part having communication bus. So it is a system totally. So the concept of system on a chip, I'll show you later on, that we have developed in our lab, the lab on a chip. This concept actually starts from here only. So here also we can see in 5th generation sensors, instead of a single MEMS sensor, we are putting multiple MEMS sensing devices inside a sensor. And the microcontroller is here also inside the sensor. So what will happen, that instead of taking measuring a single parameter, it can measure multiple parameters at a time, and according to your need, it can gives you the output. So that's the concept of sensor fusion or intelligent sensor that will build up from here only. Now the question is, why we have taken MEMS as sensing element? There are lots of advantages. First and foremost is that it is small in size, means micron level size. So we can produce lots of sensors from a single silicon wafer through batch process. So it is very much cost effective. And though the size is small, it is not having any mechanical fatigue like mechanical hysteresis or inertia problem. It's easily portable from carry. You can easily carry it from here and there. Its sensitivity is much higher, And finally, in silicon-based MEMS technology is compatible with CMOS technology. So the signal conditioning circuitry along with the sensor or actuator can be fabricated on a single chip. So that is the main advantage. And this is the three pillars of MEMS devices. First, we have to do the design. Secondly, we have to choose the material, that which type of material we are going to use. And third one is the fabrication. So this is MEMS fabrication technique. And now the applications of such sensors, AI-based MEMS sensors in different sectors. It is in case of home appliances. You can see here, this is a smart kitchen. This is a smart device where you can program actually the different recipes of cooking, and it will prepare the food according to our control program. Then lots of other applications like how much we have consumed electricity to our different home appliances. That also you can check. This is the smart bin, that if you are coming towards it without any mechanical intervention, it's showing you opening this lid. This is a multi-purpose catch leakage sensor. You can measure, detect the temperature as well as if there is any leakage of cooking gas or any other gases, carbon dioxide, etc. in your kitchen. This is the smart detector for glass break in our home. And here you can see in automobile, these days we are talking about semi-automatic car, we are talking about driverless car that Google invented. And there are lots of safety devices that we are incorporating inside our car. So while you are sitting in the driver's seat, you are aware of lots of parameters, that how your car is moving, what are the air pressure of your wheels, fuel pressure, how much is the fuel pressure. There is air conditioning compressor sensor, airbag is there for your safety purposes, crash sensors if there is any thrush of your car with any other car or any roadside tree. Then there is a sensor, that is a crash sensor, that will actually help to open the airbag and all. In case of aerospace, I am leaving that, but in case of aerospace, if you move to a normal Airbus or fighter plane, you can see lots of smart devices in the cockpits of aeroplane. So that will actually help us. So smart sensors in healthcare now I am showing. So biological MEMS devices are actually divided into two parts, biomedical MEMS or biotechnology MEMS. So biomedical MEMS actually dealing with precision surgery. These days we are talking about robotic surgery or microsurgery, biotelemetry, that through telemetering from a distant end, the doctor is doing operation, and drug delivery and other different types of biosensors that we are using. And biotechnology sensors mainly used for diagnosis purpose, for drug discovery purpose, and pathogen detection. These days we are using that for COVID detection also. So what are the benefits of MEMS technology in medical applications? First and foremost is that it actually takes small volume of reagent samples like blood or serum, whatever, that is taking for analysis. And power consumption is very less because the size of the device is very small. So battery longevity is much higher in case of this type of devices. And as its size is very, very small, so it's less invasive, and that's why it's tend to impunging your skin during our injection or something. If you remember, during our childhood, we are not at all willing to take injections But I think this days injection is a little bit less painful. Excuse me, just excuse me. Less painful, and then we can easily, if you remember our childhood days when we are taking injections, it was very much painful, but these days it is less painful because due to invention of micro needle, the size of the needle is much more less. So what will happen, the area of contact is minimized, so now the injection, then that pain due to the injection is now not that much. If we miniature the size, it will be less painful. That I'm willing to make you understand. Then, as it is a silicon-based technology, so integration is possible with a large number of systems in a single chip. So lab on a chip, system on a chip can be possible, as I told you earlier. And batch processing in a single silicon wafer, we can produce hundreds of sensors, micro sensors. So it will actually decreases the cost of manufacturing. And existing IC technology can be used for such devices. It's similar to VLSI technology, but in case of VLSI, it is a 2D thing. But in case of sensor or actuator, it is a 3D thing. So the fabrication technology for sensors and actuators are much more difficult compared to VLSI technology, but we are following the same thing, that is the deposition, lithography, and etching. But it's much more challenging, I can tell you. And we are using mainly silicon, and that is biocompatible with our body tissue. There is no harm in it. So I am willing to show you a few examples that we are using these days. This is the conventional blood pressure monitoring device, and this is the same device on our fingertip. This is on the fingertip. You can see the size of the device. Talking about injection needles. So this is the needles, micro needles. This is the ACM picture, that is scanning electron microscopic picture. This is out of plane and this is in plane. And I think some of you have experienced endoscopy. Endoscopy, actually we are using endoscopy for knowing the our internal gastrointestinal tract condition. So it is a big device, means it is fiber optic cables are there along with camera and all, and we have to put it inside our body through mouth. And we know that our body parts are not so straight. There are different types of bending is there. At the same time, fiber optic fiber also having some bending limitations. So it is quite painful when such fiber optic is actually inserting inside your body. And that's why here I have mentioned that it is uncomfortable procedure, and you have to visit some diagnostic center. It is very, very costly. And after doing endoscopy, you have some problem. You will face some problem for while you will have food, or while you will drink or something. And you have to actually spend at least 2-3 hours in the diagnostic center. All these things will happen. So this is the smart sensor. What we can say, that is lab on a pill. See the size of the pill. It's doing the same endoscopic work. And these are the different parts of this smart pill. It is containing digital camera. Size of is 35 millimeter, just like a capsule. And it is having a battery. Transmitter is there, wireless transmitter. So while it's passing through our inside parts of our body. It will take picture and it will send picture to there is an antenna, so it will send picture to doctor's console. So you need not visit, sometimes you need not visit to the laboratory diagnostic center itself. If you take it, it will take pictures and send to doctor's consoles or doctor mobile phone automatically. Or if you visit the diagnostic center also, there is no pen. No sedation is required for pen, and it will help you to detection of early colon cancer like that. Another concept is that smart pill for diabetic patients. In case of diabetic patients, those who are taking insulin, so they have to take insulin injection each time before lunch and dinner. That is quite painful, and sometimes when we are busy in work, so it is when we are busy with work, it is quite difficult to manage time for taking such insulin injection. So this is a solution for them. What is the solution? We are actually injecting a smart pill inside our body. So what is there? There are some sensors that is actually measuring body glucose. There is a reservoir filled with insulin, and there is a antenna or transmitter that will give signal whenever the reservoir will empty. And there is a long life battery. So what will happen? This glucose sensor will measure body glucose all the time. So whenever this insulin is required, the insulin will come directly to the blood from this reservoir. There are some ports, so through which the insulin will come to the body blood, and as soon as the body glucose is maintained, then it stops flowing insulin from here. And after a certain period of time, the insulin vessel will be empty. So this antenna will give signal to the outside that now it is empty. So refilling of the reservoir is required. So this is the concept of smart pill. This is another interesting concept, that is smart dust or MEMS dust. Have you ever enjoyed the movie called Mr. India? Anyone? Are you hearing or sleeping? I can't see anyone, or I can't hear anyone. What is happening? I don't know. Are you feel bored, or is it okay?
It's okay, ma'am.
It is okay?
Yes, ma'am.
Okay, okay. So if you have any query also, you can tell me. Okay. Is it interesting, or are you feeling bored? Should I go fast, or it's, what are you feeling? Should I go fast, or it's okay, my spacing is correct? Hello?
Fine, ma'am. It's fine, ma'am.
Okay, thank you. So, have you enjoyed the movie called Mr. India? Anybody? The person was invisible, huh?
Yes, I agree, ma'am.
Huh? Have you enjoyed? So, same thing will happen here. Same thing will happen here. Hello?
It is very informative, madam. It is very informative.
Okay, thank you. So, same thing will happen here. Suppose we are willing to gather information from you, but I can't go to your place. So what to do? We can put Magda. Someone's mobile phone is on. Someone's microphone is on. Please switch off your microphone. Hello. So what will happen? It can gather information from the environment, the information you are willing to get, because you can choose the sensor according to your choice. Okay. So it will gather information, then it can send information to you. So you are at the far end, can get information what is happening there. So you see the different parts of MEMS dust or smart dust. It is having IR sensor, but you can change the sensor. You see it marks it is only 12 milligram and speed is 100 meter per hour and energy is 1 milliwatt solar energy it's taking. And battery longevity is 4.5 days and it can easily float on the air like dust particle. That's why it's calling MEMS dust. Okay. So here I'm comparing MEMS dust with dandelion sheet. This is the MEMS dust. You see the size. So the size is so small that it can easily float in the air around us like dust particle. So there are lots of applications of MEMS dust. First and foremost, we can use in our military. Suppose we cannot go beyond our border. If we want to get information beyond our border, then we can put some MEMS dust there and we can get the information. So defense-related sensor network, virtual keyboard, then inventory control, product quality monitoring, smart office these days. There, it can be used as interfaces for the disabled person, like that. Okay, I'm not going into detail because time is limited. We have already crossed 40 minutes. So another 1 hour is there, na? So what makes smart dust MEMS? What are the different components of smart dust? You can see there are different components. This is the actual MEMS dust. So there are different particles like active transmitter is there. It using laser, towed and beam steering, but there is passive transmitter is also there. That is corner cube retroreflector. Have you heard about retroreflector? Do you know what is retroreflector? Then receiver with photodetector. There is a solar cell and there is a thick film battery is also there. Sensors, different types of sensors that you, the parameters you are willing to actually know. You have to put this type of sensors. Then we will go for medical prosthesis. As I told you earlier that in category of smart sensors, both sensors and actuators fall actually in the category of smart sensors. These days we are talking about laparoscopic surgery. We are talking about robotic surgery. We are talking about microsurgery. So that is also by the help of smart actuators or smart sensors. So I'm showing you a few examples. Here you can see this is the surgical, microsurgical instruments or robotic instruments. Here one is stents that is using these days for angioplasty. Few days back, our Dada, that is Shourabh Ganguly, they actually implanted some stent is actually implanted inside his artery. So what is happening in case of angioplasty? Due to overeating of what I can say, fat fat normally. So it will actually deposit it inside our artery. So what will happen? The artery will be closed like this. It is normally open like this, so blood can flow easily. But due to depletion of this fat type of material inside our artery, it will close like this. So blood actually get some restriction to pass over here. So when it actually closes the whole part, what we will do, we'll put stents inside that blocked portion in the form of a pin. You see, it is in the form of a pin. Here I am comparing the stent with a matchstick. It's just like a matchstick. And then we are opening, it regains its original shape. Actually, stent's original shape is like a netted cylinder. But while we are employed inside our blocked artery, it is in the form of a pin, so that we can put it inside our artery and then it regains its original shape like a netted cylinder like this. So it's reopen the blocked artery And once again, the blood can flow through it. So this is called angioplasty. So how do we make this? This is in case of very small size, artery size, and this is also very, very small. So by the help of a special type of material called SMA or shape memory alloy, this is a class of metal alloy that can recover apparent permanent strains when they are heated above a certain temperature. Means by changing the temperature, we can change the shape of these actuators, and when we actually change the strain or temperature, then it regains its original shape. So this is the beauty of the actuator. Have you ever thought of that when we are doing laparoscopic surgery, there are 3 holes, isn't it? Through one hole we are putting camera and these surgical instruments. Have you ever noticed the size of the holes? It is in millimeters. So how come the surgical instruments are inserted inside our body through such a small hole? Have you ever thought of during gallbladder surgery, during other surgery, stone surgery, kidney stone surgery? So all these surgical instruments, they are actually smart actuator type of thing. So while we are injecting it, they are taking some different shape. After reaching to that particular place, it regains its original shape, and then doctor is doing surgery from outside. So